Hello and welcome to our segment on ski jumping here at the BMS 17 News Channel.
First, some background on the sport of ski jumping.
Ski jumping originated in Norway. The first ski jumper was Olaf Rye, who jumped 9.5 meters in 1808. The first recorded public competition was held at Trysil, Norway on January 22, 1862. In 1863, the first known female ski jumper took place in the Trysil competition. Ski jumping has been part of the Olympic Winter Games since the first Games in France in 1924. Olaf Rye was the first ski jumper. Ski jumping has been part of the Winter Olympic Games since the first Games in 1924.
A new innovation in ski jumping is that they first put their skis in a parallel position, but skiers realize that you can get more lift by separating the skis into a V position so they can stay in the air longer. This is an example of the parallel skiing strategy.
Nations compete in 3 events: individual long hill, individual normal hill, and team, which uses the long hill. The height of the long hill was changed to 120 meters in 1992. The height of the normal hill was 70 meters at first, but it was changed to 90 meters in 1992. The goal of ski jumping is to gain speed while skiing down the ramp in order to jump off the ramp and cover a large distance. The winner is decided on a scoring system, which includes distance, style, in-run length, and wind conditions. Each hill has a target called the calculation point, or K point, which is the distance each skier aims for.
Now I will explain the physics of the in-run and takeoff. The skier sits on a pole at the top of the ramp. To initiate the takeoff, the skier lets go of the pole at the top of the ramp. He or she crouches down while skiing down the ramp in order to make the surface area of his or her body smaller, thus decreasing the air resistance. With less resistance, the skier can go faster and gain greater momentum before takeoff. The skier has gravitational potential energy at the top of the ramp, which is converted to kinetic energy as he or she releases the ramp pole. The coefficient of friction between wax skis and snow is only 0.04, which is an extremely low friction and thereby helps the skier avoid being slowed down by friction. The skier needs to reach a high velocity in a short amount of time in order to jump a long distance. The skier needs to accelerate while he or she travels down the ramp in order to increase his or her velocity. Distance equals velocity times time. With the higher velocity, the skier can achieve a longer distance.
The skiers are always accelerating towards the earth, so they manipulate their positions to stay in the air longer. The force of gravity is always pulling them down, so they need a greater kinetic energy when leaving the ramp to get a higher potential energy, so they will travel higher in the air. This is because, ignoring air resistance, Ke equals GPE, so a greater Ke equals a greater GPE. Also, GPE equals mgh. GPE divided by mg is equal to h. More GPE divided by the same weight is equal to a greater height, so the skier stays in the air longer and later. Gravity will pull the skier down at an acceleration of 9.8 meters per second squared, regardless of the y velocity. So it is important that when taking off, the skier has a greater x velocity, so they will travel a farther distance before being pulled down by gravity. Often, ski jumpers suffer from bulimia and anorexia because they want to be lighter. Mg equals weight, so a smaller mass equals a smaller weight, or a force that pulls them to the earth, and with a smaller force, they will move higher up and therefore farther. Also, in the equation F equals ma, where F is the force of gravity, skiers strive for a smaller force so that the net force pulling them down towards the earth is lessened. The skiers are in free fall during their time in the air because only gravity is acting on them. In order to resist free fall, ski jumpers lean forward to increase drag, the force opposite the relative motion of an object moving through air. Drag makes them have a greater length and more force against gravity. Ski jumpers also need lift to fly. Lift is perpendicular to drag force, so it opposes the weight of the skier that pulls them to the earth. Skiers get more lift by separating skis into a V shape because there is more surface area and more force pushing upwards so they can stay in the air longer. Once in air, the skier changes their body position to use lift, the upward force to help going through air. Separating skis gets more lift because there is more surface area. While in flight, skiers try to create an effect similar to airplane wings because the lift opposes gravity. Newton's third law is, for every action there is an equal but opposite reaction. This is similar to in ski jumping when the jumper exerts downward force on air, and air exerts equal but upward force on the jumper.
During a ski jumper's landing, the jumper has to maximize the time that they take during the landing on the ground by touching down first with the backs of the skis and slowly rotating the skis down to fully land. This is because if more time is taken to land, the force that the jumper experiences can be minimized, and therefore bodily damage can be minimized as well. The normal force of the ground is among those that act on the jumper. It is equal in magnitude to the weight of the jumper, which is its mass multiplied by the force of gravity, but points in the opposite direction. This can be problematic because when this force is imposed on the body all at once, it can harshly attack its weakest points, such as joints and the spine, which makes the jumper's landing a crucial component. Also, the jumper must create friction against the snow in order to slow down by tilting their skis slightly. This removes the problematic smoothness that the snow against the skis ensures, and creates a force working against that with which the skier is creating, thereby reducing their velocity and allowing them to experience a negative acceleration so large that they can safely come to a stop within seconds.